Hello everyone, my name is Jacob Peroni, and I'm here to present my NLP tool demo on natural language processing using spacy. So I just want to give a little background information on what spacy is before I go into the demo here. So spacy is a free open source Python library that you can download using the pip install spacy command. Its main focus is on information extraction and natural language understanding. It comes for production use with a really simple API interface. And it supports tokenization of 49 languages, and it has pre-trained NLP models that perform common NLP tasks that you would find. So spacy consists of the doc object, and the doc object contains the original text and the results of the spacy model after it processes the text. It's what you're going to run your text or whatever document you have, you're going to run it through the doc object and turn it into a doc object. All the useful information is already pre-computed and stored in there, and you're basically using access functions to get it. Even though it does tokenize the text, splits it into tokens, there's no information loss, so that's also a good bonus for it. Alrighty, so pulling up the Jupyter Notebook here for the spacy demo. So the first thing you would do if you're going to use the library is obviously do the pip install spacy command. And then once you've done that, it's downloaded. You go and we're going to go and import spacy, and we're going to load one of the pre-trained models. We're using the small model here, as seen using the SM at the end. We load it into NLP variable here. So in this first section, we're just going to show sentence detection. So we take whatever text we want, and I just loaded into a string here called text, and then we pass it to the NLP model that we loaded in, and that's going to create the doc object. And you're going to notice throughout the demo that document or token is always going to refer to the doc object, and anything with text is going to refer to the string or the raw text that you would be passing into. So then we go and set up a list to turn into sentences, and then we just print out our list. So our sentences are, this is the first sentence, and this is the second sentence, and then Python is cool is the sentences that are found. So next we're going to go through tokenization. So taking that same doc object from before, and just from the sentence detection, we go through and print tokens. And here I've also printed out the token index, so where each token is in the sentence. So you can see this starts at index 0, the next sentence starts at index 27, and then the last one starts at index 55. So now we can also remove stop words using spacing. So here we load the English language stop words from spacy library, and we load into a variable called spacy stop words. Now our previous document, we're just going to go through and load it into the no stop words using a list comprehension here. So if for each token in that doc object, we're going to check and see that if it's a stop word or not, and then if it is, it gets left out. Otherwise, it gets saved and put into the new doc object. So we have sentence, second, sentence, some punctuation, Python, and cool. Next is a lemmatization. So we're going to take our raw text. Here I just loaded into a tokens, which is going to be our doc object here. And it's going to tell us, it's going to give us the root word of some of the words, so it's all in a common space. So we just go through our tokens and we pass through the token.lemma, which gives us the lemmatization of each token in the doc object. So I can see we have the name Amelia would just be Amelia. Is has the pretense of be. Taking has the root word of take, and as such, as you can see throughout. Now we're going to go into tagging and part of speech. So we take our token and we go through our doc object, and we're going to print the token.tag and the token.part of speech, or POS as it's abbreviated here. And as you can see, this is a pronoun. We have is an auxiliary, and you can see just going down, it'll print out the part of speech and its tag. Now you can also do a display. It's called spacy. So we're going to import spacy from spacy, and here I used a different example text than what was up above. It's just learning natural language processing is cool, and then we turn that into our doc object, and then here we run displacy.render, and we pass through our doc object with the style being dependency, and this ends up rendering the dependencies of the raw text that we wanted to see. So learning natural language processing is cool. You can see the dependencies and the part of speech that it is. Now we use displacy.render if you're using a Jupyter notebook. Otherwise you would use displacy.serve and keep the rest of it the same. And you would go to this address here on your browser and it'll show up. But if you're in notebooks, just use .render. Now you can also do noun parsing, which will take the object and it'll parse out everything but the nouns. Or it'll commonly be called chunking. It'll chunk out everything but the nouns. So taking that example sentence from above, the learning natural language processing is cool. Pass it through a noun parser. So we'll call it a chunk. Goes through the doc object. Pass through .noun chunks is what the function is called. So natural language processing is found as being a noun. Now we also have named entity recognition, or NER, that we can do. So here in a named text, we can pass through Florida Atlantic University is located in Boca Raton and offers a variety of degree majors. So we put that into our data model, and then named entity recognition uses the ENT prefix, or ENT abbreviation, excuse me. So we pass it through into this loop with the doc object .ents, or entities, and then we print out the text and also what label it is. So here you can see the first part of the output: Florida Atlantic University is an organization. Boca Raton is a geographical location. You can also do this with displacy. So here you see displacy.render the doc object and use the style as ENT for entity. And you see Florida Atlantic University is highlighted with organization, and Boca Raton is highlighted as a geographical location. You can also do word vectors with spacy. So what we're going to do here is load in a bigger sized data model. So we're going to call it the same NLP, loading it in using the medium model here. The small does not work with word vectors. You have to go to the medium or the larger size data models. So here we pass our doc object into tokens with the raw text: I like to grill burgers and hot dogs on the weekends. And we're going to print the text, the tokens, as well as if it has a vector. So this will tell us whether it can be put into a word vector or not. So here you see the sentence here. All of the words can be put into a word vector. So then what we're going to go through and do is print out the text again, and pricked out the normalized vector of what it is, or where it correlates to in the word vector. And as you can see here, all the outputs here of the normalized word vector. So building on that, we can do similarity using the similarity function here in spacy. So we'll take two different texts, label text 1, text 2, and these are just going to be, for simplicity, our doc objects. So text 1 is going to be a doc object called the food was excellent, thinking maybe like review handling. And text 2 would be the service was horrible. And you're going to pass it through the similarity function. So you're going to do your first doc object dot similarity and then pass through your second doc object. And then we just print the similarity score between the two. So as you can see, it has a 0.816, which shows that the two sentences here are not very similar, and which should be evident as the food was excellent, the service was horrible. They're very opposites, excellent and horrible particularly. Next, we can also do it for just any streamlined individual entities. So we have three more doc objects here labeled into text. So we have airplane, steak, and boat. And you can see that airplane and steak, when passed through the similarity, has a very low score, whereas airplane and boat has a slightly higher score. And you're able to do this, and this is obviously a really simple example, but you can go through and find similarities between different documents, different text, or different things in your text, and see how correlated they are, and pass it through all that. So this ends the my demo on using spacy with Python. Thank you, and I look forward to seeing everyone else's presentations.